Welcome to Conceptual Chemistry GCE O Level series. This is Unit 4, Part 2, Element Compounds and Mixtures. As there are 26 letters that make up the English alphabets, yet when these letters are combined in different ways, thousands of different words can be formed. Just as letters are used to build different words, elements are the builders of compound. At present, there are 118 elements have been discovered, though IUPAC, which is International Union of Pure and Applied Chemistry, lists 112 officially named elements. 92 occur naturally, while the rest are man-made or synthetic. These elements can combine to form thousands of different compounds. So let's learn what basically a compound is. A compound is a substance which contains two or more than two elements that are chemically combined together in a fixed ratio. Always remember, compounds will be having a fixed ratio of their constituent elements. As I told you, the words have a fixed spelling. Changing or removing any one of the letter will give a very different word altogether. Similarly, compounds have a fixed composition. Changing any one of the elements in the compound or changing the ratio of the elements will give a totally different compound altogether. Let's have a look at water molecule. This is water, which is a compound, and it is made up of two elements, hydrogen and oxygen. Only two hydrogen atoms and one oxygen atom can make a water molecule. So the ratio of hydrogen and oxygen is 2:1, and its formula is H2O. Changing this ratio will give a different compound. For example, adding one more oxygen atom gives a ratio of 2:2. So here we will add one more oxygen into it. So now the ratio is 2:2, and the compound will be now hydrogen peroxide. Hence proved that changing the ratio of constituent elements will change the entire compound. So what is composition of compounds? Compounds are composed of either molecules or ions. Ions are basically electrically charged particles. They are composed of a positive ion and a negative ion. This is the example of molecule. Here, one oxygen is connected with two hydrogen atoms and it's a triatomic molecule. So this is how this occurs. Next is sodium chloride. It is composed of two ions, sodium ion and chloride ion. Both of them are connected with one another with the help of a ionic bonding. So this is how a compound will be formed with the help of ions. Now there is a very important question. Does a compound have same properties as the elements that form it? Always remember that the compound will never have the same properties as its constituent elements. What is the reason behind it? Let's see this example. When magnesium burns in the presence of oxygen, what happens? Magnesium oxide will be produced. So there are two reactants, magnesium, which is silver solid, whereas oxygen, which is a colorless gas. Both of them are reacting together to yield magnesium oxide, which will be white solid. So the properties of magnesium oxide will be totally different from magnesium and oxygen. Why it will be totally different from these two constituent elements? Because now this is a totally new compound with totally different chemical composition and chemical properties. So that's why compounds will never be having the same properties as their constituent elements. Why CO2 is called as carbon dioxide? Why this specific name is used for it? Actually, all the compounds are having particular names. There is a complete nomenclature and there are certain rules which assign names to the compounds. So we will be doing it in detail. Rule number 1 is, if compound contains both metal and non-metal, the metal is usually written first in the formula. Always remember, whenever there is a metal and a non-metal in the chemical formula, so the metal will be written first. Look at this. Sodium is a metal, so it will be written at first, and chloride is chlorine is the non-metal, so it will be written after the metal. We can take any other example as well. We can take example of magnesium chloride. So again, magnesium is the metal, it will be written first, and chlorine is the non-metal, it will be written after magnesium. Next rule is a compound with only two elements often ends in IDE. IDE is the suffix which will be used whenever a compound is composed of only with two elements. And look at their ratio. The ratio is different. It depends upon the compound, but the elements are two in each of the compound. The first compound is sodium chloride. So why are we giving this name to it, sodium chloride? Chloride has IDE suffix at the end because there are two elements in this compound. If you look at the second example, which is magnesium oxide, so we will be having this formula, magnesium oxide. Here you can see again two elements are used in order to compose magnesium oxide. So oxide, we will be having IDE as a suffix at the end of all of these compounds. Next is carbon dioxide, CO2. Again two elements are there, one is carbon, one is oxygen. Lead bromide, again we are having two elements here, so again IDE will be used as a suffix at the end. Next rule is a compound contains hydroxyl is named as hydroxide. Always remember, whenever hydroxyl group is present, so the compound will be having a suffix hydroxide, such as sodium hydroxide. This is the formula. This is sodium hydroxide. Sodium is the metal, it is connected with hydroxide group. So we will be having, its name will be having hydroxide at the end, or as a suffix it will be used. Next is calcium hydroxide. So again here we will be having hydroxide as a suffix. Next is copper 2 hydroxide. Always remember, we are not going to read it out as copper 2 hydroxide. We will read it as copper hydroxide. But this 2 is representing the oxidation state of copper. So it will be copper plus 2 and hydroxide. So how are we going to write it down? We are going to write it like this. I will teach you that how ionic formulas can be generated for ionic compounds. The rules are given in the coming slides. Next rule is a compound with an ion containing oxygen will ends with 8. Calcium carbonate. See, it is containing one ion, which is carbonate ion, CO3. It is the carbonate ion, so that's why we will be having suffix 8 for it. Nitrate, silver nitrate. Look at this, silver nitrate. Here again we are having this ion, which is a polyatomic anion, so that's why we are going to use 8 as a suffix at the end. There are some chemical formula that contain brackets. For example, we'll take example of lead nitrate. So this is the chemical formula of lead nitrate. To find the total number of nitrogen and oxygen atoms within the brackets, we multiply the number of atoms of each element with the subscript located outside the bracket. So each of these atoms which are present inside the bracket will be multiplied by 2. In more simpler way, I'm going to write it down just like this. Here we are having lead. Here we have nitrogen, 2 atoms of nitrogen, or in the diatomic state, and here we have oxygen, 3 oxygens, and this 2. This subscript 2 will be multiplied with both of them. As a result, we will be having 1 atom of lead, 2 atoms of nitrogen, and 6 atoms of oxygen. So this is how we are going to see that how many atoms are there and how are we going to write the chemical formula for all those compounds which are having brackets. The Roman numerals are used to denote oxidation states. Oxidation state will be done in the coming units in detail. So we are having here 2 compounds, iron 2 hydroxide and iron 3 hydroxide. So the formula of iron 2 hydroxide or iron hydroxide will be written as FeOH2. So it is iron dihydroxide, whereas the next one will be written as iron trihydroxide, because in the first one the oxidation state of iron is +2 and hydroxyl is -1, and in the second one it is +3 and hydroxyl is -1. So these are certain rules to do it. Next point is for covalent molecules. For some compounds, we usually name entire compound by counting the number of different atoms, such as carbon dioxide. See, carbon dioxide, di means 2. 2 oxygens are there. So we are counting the numbers of this non-metal. Carbon monoxide, again, mono means 1. So 1 oxygen is there. So we are counting the number of atom over here. Next is, there are some compounds which are having their common names, such as water, ammonia. So ammonia has its specific name, whereas water has its specific name. This is the formula of water, this is the formula of ammonia. Next is decomposition of compounds. There are different chemical processes which are used to decompose compounds, such as thermal decomposition and electrolysis. Thermal means using heat, electrolysis, electro means electricity, lysis means to break down. So thermal decomposition involves heating a compound strongly. For example, look at this investigation. Here we are having mercury oxide, which is heated strongly. It decomposes to give elements mercury and oxygen. So here in this investigation, you can see that mercury is heated. This is mercury in the test tube, and it will be heated with the help of Bunsen burner or any kind of fire, and then it will be heated and converted or decomposed into mercury and oxygen. So what will happen? Mercury will be decomposed into mercury and oxygen, and this delivery tube will be taking up this oxygen gas, and this will be collected here at the top, whereas mercury will be taken over here in this portion. This is how decomposition of mercury occurs, in which mercury oxide will be converted into mercury and oxygen. A very important point over here, if you remember, I taught you displacement of water for the collection of gases in experimental technique unit. So there we have used this complete setup. So here you can see this is used to collect oxygen. If you remember that the displacement of water was important for all those gases which were not soluble in water, which were insoluble in water, and we know that oxygen is insoluble in water, or sometime it is slightly soluble in water. So this setup is used here in the decomposition of mercury oxide in order to collect this gas, because this will be collected, oxygen will be collected as a gas, whereas mercury will be collected as a liquid, because it's the only metal which is found as liquid at the room temperature. Again, a very important point, always remember, when all the elements which are used in a compound are non-metals, so we will call it as a molecule. We are not going to call it as a compound. We will say it's a molecule. Why is it a molecule? Because here you can see carbon is a non-metal because it belongs to the p block, and dioxide means 2 oxygens. Oxygen is also a non-metal and it is in the p block of periodic table. So this substance is composed of 2 non-metals, so it's a molecule, it's not a compound. These are the minor mistakes which students used to commit in their externals, and their marks get reduced. So you have to take care of these small things. If a compound is composed of a metal and a non-metal, then we are going to call it as a compound, such as sodium chloride. Sodium is a cation, chloride is an anion, so it is a compound. Whenever a substance is composed of a metal and a non-metal, or in another way you can say a combination of metal and non-metal, is called as a compound, whereas a combination of non-metals is called as a molecule. Next is a mixture. Have you ever wondered what is a sandwich in the perspective of chemistry? Basically, sandwich is a mixture. Why is it a mixture? Because you can easily separate out the parts of sandwich you can separate out bread, vegetable, and meat which is used into it. These all things are not chemically combined in a mixture, so that's why it's very easy to separate them out. So basically, mixture is made up of two or more than two substances that are not chemically bonded. This is the major difference between mixture and compound, that in compound, the constituent elements are chemically bonded at a fixed ratio, whereas in mixture, the constituent compounds are not chemically bonded. Examples are hydrogen and neon. We can never chemically combine hydrogen with neon, because hydrogen and neon, both of them are having totally different electronic configuration. So when we will mix hydrogen with neon, so there will be just a mixture of hydrogen and neon, but not a compound. Water and carbon dioxide. Carbon dioxide is slightly soluble in water, but somehow it's insoluble in water. So there will always be a mixture of carbon dioxide and water. One of the examples of mixture is alloy. Basically, mixtures of metals are called as alloy. The details of alloy are given in the coming chapters, but whenever there is a mixture of metals with the other elements, such as metals or non-metals, so we call it as alloy. So we can say that alloy is basically a mixture of metals with either metals or non-metals. One of its best example is that most wind instruments such as the trumpet are made of brass, which is an alloy of copper and zinc. Always remember, brass is the alloy of copper and zinc. Copper is a metal, zinc is also a metal. So next is difference between compound and mixtures. Compounds are made up of single substances, whereas mixtures can be made up of two or more than two substances. Elements are always in a fixed ratio in compound, whereas there is no specific ratio, and the ratio will be variable in mixtures. The properties of compounds are totally different from the constituent elements, but the properties of mixtures are always same as the constituents of a mixture. Let's suppose again, if we will take the example of sandwich, if we will put some ketchup in the sandwich, so we will get the flavor of ketchup. If we are going to add some mayo, so we'll get the flavor of mayo. So it means that mixture is basically having the properties of the constituents. Next is separation. It's very difficult to separate out compounds, whereas it's easy to separate out mixture. So in order to separate out different constituents of compounds, we need to do certain processes, chemical processes, such as electrolysis and thermal decomposition. There is usually a heat change when compound is formed. Reactants are hyperactive, so there will be either a reaction will be exothermic or it will be endothermic in order to produce or yield the product. Whereas there is a very little change in case of mixture. Checkpoint. Which one of the diagram A, B, and C represents oxygen? Look at this, oxygen. Which one is an oxygen? B is oxygen. Why is it B? Because oxygen is found in a diatomic state. And here you can see that there are two atoms together. So it means B is the accurate answer for part A. A mixture of oxygen, O2 and chlorine. We know that chlorine is a greenish gas. So here you can see Cl2. Again, diatomic molecule. So these green molecules are chlorine, whereas this red one is oxygen. A mixture of ammonia and carbon dioxide. Ammonia will be having a geometry like this, whereas carbon dioxide is having a linear geometry or structure. So here you can see this is ammonia, whereas this is carbon dioxide. At the middle we are having carbon, and this one is carbon, and these two are oxygen. In case of ammonia, this black molecule is nitrogen, and the rest of the three white small atoms are hydrogen. Thank you so very much for your attention.